started with kind of a confusing example because we didn't rotate around an axis. And I want to do another example where we're not just rotating around the axis. So I want to use the same curves from example 6a. So if you look back at that one, our curves were y equals x and y equals x squared. So we used those on the previous example too. And we rotated them around a horizontal line, y equals 2. This time I want to rotate them around a vertical line, x equals -1. So if we start with our little sketch that we've done on the last two examples, we found that those two things intersected at 0 and 1. So if we did a rough sketch, there's your line, and then we had that portion of a parabola. If I take the line x equals -1, where is that? What does it look like? X equals is what kind of line? All lines are straight. Vertical line. Okay, vertical line at -1. I'm not going to have enough space here. Okay, let me redo my picture. I don't have enough space. Okay, so here's the x equals -1. So to draw your picture, first kind of reflect this. So this is 1 away from that line, so it'll go 1 the other direction. So that's just the reflection. So we are spinning that. So we are getting something like this. Okay, it's solid on the outside, hollow in the middle. What? My pictures are not very good, but it's like a bowl with an open bottom. Okay. So we need to integrate. Is this one where you would integrate with respect to x's or y's, do you think? Probably y's. Why? Okay. If you look at your x's, depending on where we're at, the x's change, don't they? Now, if you start at the bottom, your x's are here and here, but as you go up, those x's get wider. So I don't have a starting and a stopping point for my x. But if I did a horizontal cross section, we have definite starting and stopping y's. So in general, typically if you're rotating around a horizontal line, then usually you will integrate with respect to x because you'll be able to do vertical cross sections. If you are rotating around a vertical line, then most of the time we're going to end up integrating with respect to y. So we are going to integrate. If I'm looking at y, my lowest y value is 0, my highest y value is 1. Then we would do pi times our radius squared, but we have 2 of them, so you'll have to subtract them. And we already said we're going to do dy. Okay. Now we need to figure out what's going to go in that little parenthesis. So if you think about a cross section, okay, if I take a horizontal slice of this, it is circular, so that's why we're doing the pi r squared. The radius, goes from here. The first one would have to go all the way out to the edge. Okay, if I wanted the distance from the axis to the edge, that would just be my x squared, except we need to be in terms of y, so what would we have to do there? So it'd be the square root of x. That's the distance from the axis over. How much more do I need to add to that? 1, right? Because we moved 1 this direction. So it would have to be 1 plus the square root of y. For the other one, the distance to the curve from the x-axis would just be y equals x, so we could just do y. But we have to be 1 further than that, so it would be a 1 plus y. Everybody with me there? What do we do now? New square. You can pull out your pi if you would like. So to square that we have to FOIL, so it would be 1 plus 2 radical y, I'm going to write that as 2y to the 1/2, plus the square root of y squared would just be a y, minus 1 plus 2y plus y squared. Okay, so then if we subtract, distribute the negative, the 1's cancel, we have a 2y to the 1/2. Y minus 2y would be a minus y squared. So that's something we can integrate. Add 1 to your power, so that's why the 3/2. Means you need a 2/3 in front times the 2 that's already there would be a 4/3. Minus a 2y squared minus 1/3 y cubed.
Wouldn't that be a 1/2 y squared?
Yes, thank you. Alright, if I plug in a 1, we get 4/3 minus 1/2 minus 1/3. Minus, if you plug in a 0, we just get 0. 4/3 minus 1/3 is 1. 1 minus 1/2 is 1/2. So you just have pi times 1/2. So we get pi over 2. Okay. Is that one right? No. Let's look at so my function f of x is equal to 5x and g of x equals x squared, and R is the region between the graphs f and g on the interval 0 to 3. Find the volume obtained by rotating it about the x-axis. So we need a picture. Okay, we're going to be going from 0 to 3. So if I start here, plug in a 0, I get out 0. If I plug in a 3, I'm going to get 15. This is just a line. I'm going to count by 3s. Okay, g of x equals x squared, so 0 squared is 0. That'd be 1, 1, 2, 4, 3, 9. Are these curves actually intersecting at the end then? No. But I said we're looking at the region between them here. So we've got this little piece. And I am rotating that around the x-axis. I did not make my scale very consistent, did I? Okay, so if I just reflect it, we would have 3, negative 15 for the line. X squared is a parabola, so it was curved. Let me flip that down. Looks like that. Looking at this region here. So we rotate around a horizontal axis. I told you if you rotate around a horizontal line, you're usually going to integrate with respect to the x, because we have a definite starting and stopping x value. If we look, depending on where we at, the y's vary, so we don't want to use that. So we'll integrate. My x started at 0 and ended at 3. Okay, we'll have to do the area of the outside, which these are all circular, minus the area of the inside. So, the outside. What would be my outside radius? It's the 5x. So it's pi times 5x squared. And the inside is the x squared. So pi times the x squared squared. So as long as you're rotating around an axis, you don't have to have anything fancy with your radius. It's just your function. So we could take out the pi. So we get 25x squared minus x to the 4th dx. So antiderivative of 25x squared would be 25/3 x cubed minus 1/5 x to the 5th. If I plug in a 3, 3 cubed is 27, divided by 3 is 9, so 25 times 9, 25, minus 3 to the 5th, 243 over 5. Minus, we plug in 0, we get 0 minus 0, which is 0. Let's see, we would need a common denominator. Is that right?
1,125.
Yeah. Okay, so then we get pi times 82 over 5, so 882 pi over 5. Any questions on that? one is different than all the others. I just wanted to at least talk about one example where it wasn't just rotating a curve around an axis, just to show you that we can use the same concept with different shapes. So this one, I have a pyramid that's 4 units tall with a square base, 3 units on the side. So if we were to draw a picture, okay, pyramid, the base is square, hopefully you guys are slightly more artistic than me. So those are 3 and my total height is 4. Okay. Find the volume of the pyramid. So we have used a formula for volumes of shapes like this before, but without using the formula, we could use the strategy that we have been. I don't have my x and y axis drawn, but let's assume we take our xy axis and we just center this thing at 0, 0. So the base is sitting on the x-axis and it's going up from there. We would need to look at a cross section. So if I slice the top off this and looked at this cross section, what shape would we be looking at? A square. So for area of the cross section, we're not doing pi r squared this time. How do you find area of the square? Length times width. Okay. We need to figure out what the length and width are, a formula for any given point along the way. Okay. To do that, let's talk about similar triangles for a minute. So this whole thing has a base of 3 and a height of 4. If I took my cross section, you would have this little triangle up here. We don't know the base, let's call that B. We need some kind of expression for the height. Okay? If this is sitting on the x-axis, then the distance from the x-axis up to our cross section is what? Y, right? It's your vertical distance. And the whole thing is 4. So to find the difference, you would do 4 minus y. Okay, so the height of this little triangle is 4 minus y. So we could set up a proportion to find our base. Remember doing proportions with similar triangles? So you could say like 4 over 3 equals 4 minus y over the base. Cross multiply. So if I divide by 4, the base is 3 minus 3/4 y. So we are going to integrate here. I think it would probably be easiest to do this one in terms of y. So we said we are setting it on the x-axis, so my lowest y value is 0, and my biggest y value is 4. Then area of the cross section, that was a square, so length times width. So it would just be the 3 minus 3/4 y squared, because it's a square, those sides are the same, dy. So if I FOIL that out, we get 9 minus 9 over 2y plus 9 over 16y squared. So antiderivative, we get 9y minus 9/4 y squared. 3/16 y cubed. So if we plug in a 4, we get 36 minus 4 squared is 16, divided by 4 is 4, times 9 is 36. 4 times 4 is 16, so those will cancel, leave us with a 3 times 4, which is 12. Minus, put in 0, you get out 0. So we get a total volume of 12. Okay, any questions? So, your homework, I want to add problems 11, 15, and 17, and these are all due Monday.